Hi everyone, this is lesson 3.5, Write and Graph Equations of Lines. This is going to be the first video of 2 videos for this lesson, so we're going to split up this lesson into 2 days. And the purpose of this lesson is to review how to write equations of lines in slope-intercept form, including parallel and perpendicular lines, and we're going to look at maybe a couple of new situations that you have maybe not experienced or solved yet from Algebra 1. Okay, and we'll also be relating all of this back to, your parallel lines with the transversal cut through them. So remember, this all ties together with lessons 3.1 to 3.3, which was also about angles formed from lines. All right, so last lesson you reviewed slope, so we're not going to talk about this too much, but if you need to write this formula for slope down, then do so. Vertical and horizontal lines. The difference is that vertical lines have an undefined slope. So you could just say UD for undefined. And that's when you get a number divided by 0. You can't have 0 in the denominator. So if you ever get 0 in the denominator, you can even check on your calculator. So it'll tell you, like, for example, 3 divided by 0 is undefined. So you can't divide by 0. And then the equations are like, okay, so the vertical lines go like this, and they cut through the x-axis. They never go through the y-axis unless they are actually on the y-axis. But so then their equations, if they cut through the x-axis, then their equation is x equals whatever number it cuts through. Please note, though, that these numbers are not going to be the same. So these are not the same. They might be by coincidence, but whatever number you get here in the numerator is just what you get when you add or subtract the two numbers to get the slope, which ends up being undefined. So these two numbers are not the same. This number here is what it crosses through on the x-axis. That's how you can figure that out. And for example, if the numbers were like 3, 7, and 3, 8, then those would be, the equation would be x equals 3. So whatever number is in the x. So horizontal lines are totally opposite. So they have a slope of 0, and they go through the y-axis. So their equations are y equals some number. And once again, these numbers here are not the same. So parallel lines have the same slope, but they will likely have different y-intercepts. If they have the same slope and same y-intercept, then that means they're just the same line. But they'll have the same slope, different y-intercepts. Perpendicular lines have opposite reciprocal slopes. And they may have the same y-intercept. So that just means that their intersection point would be on the y-axis. So like 2 and -1/2 would be opposite reciprocals. All right, slope-intercept form is y equals mx plus b because it gives you the slope and the y-intercept. So it seemed like you were familiar with this when we were doing a little bit of graphing for our algebra review in one of the other edge-elastics. But m is your slope, b is your y-intercept, and it's always written as y equals. And then xy is just a point, or you can say variables, a point. All right, so let's look into some examples. So whenever you write equations in slope-intercept form, you want to determine the slope, and then plug in the slope for m in one ordered pair for x and y into the equation to solve for the y-intercept. We write the equation in slope-intercept form with only the slope and y-intercept filled in, and the x and y as variables. So for here, it gives us the slope, and the y-intercept is -7. So here, all we need to do is just plug these two things into the equation. So y equals -3x for the slope, and then -7 for the y-intercept. Okay, so that one was easy. Number 2, a vertical line through 2, -8. Vertical line, remember, would be x equals, so it's x equals whatever passes through the x, which would be 2. Here, horizontal line is y equals whatever passes through the y, which would also be 2 in this case. All right, and then here it gives us a point, a slope, and then a point that the line passes through. So what it doesn't give us is the y-intercept, which is the b. So we are going to need to solve for b by plugging in these 3 things into y equals mx plus b. So this would be an x, this would be a y. So the y is going to be -4, the m is -3/4, the x is 8. I'm going to put 8 over 1 just so I'm multiplying a fraction by a whole number. So I'll put the whole number over 1 to make it a fraction, and then plus b. That's what we're trying to solve. So if you remember from algebra, the first thing we would do is simplify this part, the m and the x. So we've got -4. Now this would simplify, 4 and 8 can cross-reduce as 1 and 2. So this would be -3 times 2 over 1, which would be -6. So if we've got -6 plus b, and then to solve for b, you would add the 6 over. So then you get 2 equals b. So now that we've found b, we can plug that back into the slope-intercept formula. So y equals -3/4 x, and then plus 2. That would be your final equation. All right, an undefined slope, which means it would be vertical line, x equals, through this point, so x equals whatever the x is, -5. And then next one, parallel to. So parallel to means same slope. So it's going to have this same slope, but it goes through this point. Now careful, this is not a y-intercept. This is actually an x-intercept, which is just another point. So we're going to have to do the same thing we did for number 4. So we'll start with, this would be our x, this would be our y. So we'll start with y, which is 0, equals, plugging it into y equals mx plus b. Maybe you write down the equation first, and then plug in what you know. So -1/2 is the slope, because the slopes are the same if they're parallel, times -2 for x, and we're going to write -2 over 1, and then plus b. So for this, when we simplify this, the negatives are going to cancel, so there are 2 negatives, and then 2 divided by 2 cancel to 1. So this all just simplifies to +1. So we have 0 equals 1 plus b. So if you subtract the 1 over, you get -1 equals b. So then your equation would be y equals -1/2 x minus 1. All right. Next problem. Let's see. How many more do we want to do? There are quite a few more examples in this lesson, but I'm going to let you do some of them on your own. So I have an idea. Let's look at number 8. So it's through point P and perpendicular to line AB. So that would mean it's perpendicular to this line. We have to find the slope of line AB. So this would be just using the rise over run from B to A. We're going down 1, 2, 3 over 1. So -3 over 1, or just -3. So then the perpendicular slope, M perpendicular, would be positive, the opposite reciprocal, +1/3. So then it says to write the slope-intercept equation of the line described. And then it goes through this point. So now one thing we can try to do is find the y-intercept by graphing. That might not always work, so you would have to use what we did in number 4. But let's go ahead and try it. So if we go from P, we go down 1 over 1, 2, 3, because that would make a positive slope, then we do find the y-intercept. So the y-intercept is 1 in this case. So then we could write our equation. It's y equals 1/3 x plus 1. Right? And we're going to do one more from this lesson, and that would be number 10. So for number 10, we want to write the equation of just the line that's graphed. Okay, so let's find the slope between these 2 points first. So you can use slope formula, or you can use rise over run. So we'll do 1, 2, 3, 4, 5, 6. So you're rising 6, and you're running 1, 2, 3. So the slope is 6 over 3, which is 2. And the y-intercept looks like it's here at -5, but let's use the slope to double check. So this would be 2 over 1. So you go down 1, 2 over 1. So it does in fact land at -5. Be careful, because even if maybe it looks like it lands on a certain point, you can't say for sure, because you can't always trust your graphs. So use the numbers, use the slope, or if that doesn't work, then you would have to plug it into y equals mx plus b. You would plug in 2 and then another point to solve for b. So then our equation would be y equals 2x minus 5. All right, so I think that gives you an idea of how to solve these problems. The other ones that were in the notes were very similar to these, so I'm just going to let you practice those tomorrow in the edge elastic. All right, and the next lesson will be similar to this, just a little step up, okay? All right, so have a great day, everyone.